Okay, so we are going to learn about radical expressions and how we can go from radical form to exponential form. So when I say radical form, I mean something where I have a root or an index the radical sign, which is this little squiggly. This denotes that this is in radical form. And then the thing that I have underneath this radical sign, we call that the radicand. This is what's underneath. Okay, so let's say we have something, whether it's a number or a variable. We're going to call this the base. And each base has an exponent. We can also call that the power. And those are all of the components of radical form. So if we were to compare this to exponential form, where we have a base and we have a exponent or power. Now in exponential form, we're going to say that the power is actually a fraction and the denominator is the root or index. Okay, so we know that this is in exponential form because it has only exponents. No radical signs. Okay, so exponents and roots, hello sweetie, undo each other, okay? This is the same as add or subtract, or the same as multiply and divide. So doing one thing undoes the other one. So if I'm squaring something, the square root would undo it. So squaring, square rooting, where the root is 2, that would undo it. If I had something cubed and I were to cube root something cubed, they're opposite things happening. So if there is no number here for the index, no number, the index is 2. Meaning square root. Okay, so here I could say the exponent or power is 1 and the root or index is 2. Here's the exponent or power. Here's the index or root. Exponent on each and both is 1 and the root here is 4. So I'm going to have you guys pause and see if you can get these 3 problems written in radical form. Okay, let's see how you did. So here we have a power, and here we have a root. So my square root, I don't have to write it, but I can. We can put a little 2 in here. And then my radicand, 49p to the 4th. We don't have to write it, but we could. Has an exponent of 1. Okay? So here I have a power and an index. And my radicand, we could say, has a power of 1. And the index here is a cubed root. Now you'll notice these both could be simplified, but just to get our way about us, let's just keep it simple like this before simplifying. So now here you'll notice each is being divided by 2. So I could rewrite this as 49 that has a power of 1, b that has a power of 5, and both of these exponents are being divided by 2. So here I have my power and my root. Here I could say this is a square root. I don't have to write the 2. And then here's my radicand. And I could say that the whole thing is to the power of 1. I was going to circle it, but changed my mind last minute. Okay. So now, let's see if you can pause the video and get these 3 equations written in exponential form. All right, let's see how you did. So here's the power. Here's the root. So the base is going to stay the same, 3k. I've got the power, and I've got the root. Here there is no root listed, so we know it's 2. Now this is a little bit trickier. If I throw some parentheses on here, we can see that the power and the root, and we'll have the radicand the same, the power and the root. Okay, here we've got the power, here we've got the root. The radicand is going to stay the same. This is our base. We've got the power. We've got the root. And this is our final answers.